Hey guys, today we're going to start up on 4-6 or 4.6, and we'll spend today and tomorrow on it. However, we're not going to introduce a lot of new things today. A lot of what we did yesterday will apply in this lesson and stuff we've done in this chapter. So the warm-up's a little tougher. Okay, you're going to start out with the easy ones, 1 through 3 there. Then I'm going to move it down to the more difficult one, number 4. Okay, so get cranking on that. Okay, can I have your attention up here? How many are done with 1 through 3? How many are done with 1? All right, 2. Almost done with 3? Getting close? Okay, I'm going to go and start number 1. What can I take out of number 1? I can take out a 10x, yes. Okay, always take out a greatest common factor first. 10x times what is 10x cubed? X squared. 10x times what is negative 40x squared?
Negative 4.
Okay. 10x times what is 40x? All right. And then from there, we've got that quadratic that we always try to get to. We can factor that. X minus 2 and x minus 2. Solutions. What's this solution? 0. This solution? Positive 2, and this one? Positive 2. Now, if you're graphing it, it's important to list multiple solutions because you know where things turn and stuff. Unless it says list the multiple solutions, and it's okay to just write each solution once. You don't have to list the multiplicity there, unless it asks for it. So 0 and 2. Okay. How many got it? Good job. Any questions? Okay. Dad, you okay?
Oh, yeah.
Sure? Rory?
Since you have the answer, there's 2 2's, like, because you only wrote 1, 2, and x, like, do you have to write both, or?
Yep. You don't have to, remember that if you're graphing, it's important to list them both. If you're solving, you don't have to. Okay? So, let me go through it once more. I just said this.
No, I understand.
You won't get marked down if you list it twice. Okay? But you don't have to. Okay? It only is important right now when you're graphing. If it says list the multiplicity or multiple zeros, then list multiple zeros. Okay? But if it doesn't state that, it just says solve, it's okay to list it once. If you listed it twice, I wouldn't mark you down. Okay. All right. Number 2. 4x squared, 8x squared, or 4x to the 4th, 8x squared, and 4. Sketch the graph. So first find our zeros. So our zeros means we set f of x equal to 0. We take out a greatest common factor. In this case is 4. And 4 times what is 4x to the 4th? And 4 times what is 8x squared? And 4 times what is 4? All right. And so from there, can we factor any more? Yes, that factors 2. Good. So those of you that still struggle with that, remember that is x squared to the 2nd minus 2x squared to the 1st plus 1. It's one way to think about it. All right? And that allows you then to think of it as a quadratic. Or if it makes it easier for you, you could say, well, x squared actually, I'm going to call x squared y, so I can rewrite this as, rather than x squared squared, I could just write it as y squared minus 2y plus 1, if that helps you to factor it. It's kind of up to you which method works better for you. But either way you go, 2 things to multiply to make 1 and add to negative 2 are negative 1 and negative 1. And then in front, we have our x squared. So if you would have done it this way, you would have ended up with y minus 1 times y minus 1, and then you would have replaced the y with x squared. So you would end up back here again. And we have our 4 on the outside. What are these things called? Difference of 2 perfect squares. Yes, so we get x plus 1, x minus 1, and for this we also get x plus 1 x minus 1. So we've now factored that completely. If we're going to graph the function, we should know our zeros. This one is -1, this one is 1, this one is -1, that one is 1. So -1 appears. -1 appears twice, and 1 appears twice. As a multiplicity of 2. Okay? Which means when I graph it, okay, this is x to the 4th. It has an end behavior of up, so it's going to start up here, it's going to end up here. It has a 0 at -1, and it has a 0 at 1. And because it has a multiplicity of 2, it repeats itself twice. What happens right here? Bounces. So we go down here, bumps back up. Where's it cross the y-axis? At 4. Our constant. That's our y-intercept. That's when x equals 0. We plug in 0 here. That's gone. Plug in 0 there. That would be gone. We'd be left with 4. Okay, so it's going to cross here at 4. And then it's going to come back down. And once we get to 1, what happens? It goes back up. Okay? There we got it. So that's our quick sketch. Okay, number 3, find all the real zeros. So this is where we start picking up a little more difficult. What should we do if we have 4 terms? Well, what's the first thing you should always do? Look for nope. Before we look for factor by grouping, what should we do? Yeah, greatest common factor. Is there a greatest common factor? Nope. Now we go to factor by grouping. So if I group these, if I take out an x squared here, I get x minus 5. Am I going to get an x minus 5 here? Nope. If I group maybe this one and this one, we could group different. We could go x cubed and -2x. I would end up with x minus 2, right? Or x squared minus 2. Would I get x squared minus 2 here? No. All right, maybe these two. Well, I could take out an x. I'd be left with a 5, but I'm not going to be left with a 5 if I group. So factor by grouping doesn't work, no matter what groups you try. So what do we need to do now? Tindall?
Do we do like the theorem where you do the 24 over 1, and then like 1 over 1?
Yeah, you list all your possible solutions. Yeah. So yeah, you do all that stuff. Now remember, our goal is to get it down to what value or what degree? Second degree. Okay? So, as Kendall pointed out, you do that one thing where you list like the 24 over 1. Yeah, you take all the factors of C. These are all your possible solutions. So 1, 2, 3, 4, 6, 8, 12, thank you. It's bad when you have to zoom out because there's so many. 12 and 24. And then you have to divide by all the factors of A. Luckily for us, A is 1. So it's kind of redundant putting a 1 under it, but I do it just so we can see what's going on. And then we're actually testing all the plus minuses. All right, how many possible solutions could there be? Tell your neighbor. How many possible real solutions could we have? Okay, everyone on your fingers, how many? If you have more than you have fingers, you're wrong. There are 3 possible solutions because it's a
my goodness,
third degree. Okay? It's third degree. Could only cross 3 times. That's the maximum number of times. Okay, maximum number of solutions. What's the minimum number of solutions? On your finger, please. Minimum number of real solutions you could have here. Should add the word real. What's the end behavior of this graph? Down, up. What is the minimum number of real solutions? It has to cross at least once. Right? I mean, if it starts in the bottom, ends at the top on a graph, it starts down here and ends up here somewhere on the top. It has to cross this somehow. It's not going to play leapfrog. Okay? It's going to cross. All right. So, with that being said, we need to test them. Use synthetic division. First one I'm going to test is 1, and I'm actually going to test that without synthetic division just to see if it works. I'm just going to add my coefficients. 1 minus 5 minus 2. That's 1 minus 5 is negative 4. Minus 2 is negative 6 plus 24. Did 1 work? No. Now I'm going to test negative 1. I'm going to test negative 1 actually using synthetic. It's a little harder to do it the way I just did. So if we go through it, does 1 work? Or negative 1 work? It doesn't work? So I'm wasting my time? Okay. Well, you should just be able to look at your paper and go, no, it didn't work. All right, as a remainder. Doesn't work. All right, so which one does work? 3 worked? Anything before 3 works? Negative 2 works? Okay, let's try negative 2. How do I know? Well, we're testing it right now. Other people said they tested. Have you tested it? Yeah, hey, we got a remainder of 0. It works. So we have, how do we write this as an expression?
X plus 2.
X plus 2 times 1x squared. 7x plus 12. All right? Does this factor? Total yay. So x equals?
-2, 4, and 3.
All right. Okay, question is, was it difficult on that one? Was it consuming? Time consuming? Takes a little longer, but once you learn it, it's not terribly bad. Any questions? Dallas? No? Yeah, pretty cool. Big donut. Sprinkles. Okay. All right, next one. Number 4. Okay, those of you struggling, hopefully you tried a greatest common factor first. Did it work? No, but I'm glad that you tried it. Does factor by grouping work? No. Okay, so the next step is list all your possible zeros. Okay, that's a lot of zeros. Well, it's not a lot, but it's a messy bunch of zeros, I guess. One way to think of it. Okay. All right. So you're trying to find the zero, so we set this equal to 0. And then we say, well, possible solutions. Hey, C's easy, man. It's just 1. That's awesome. But then you have to go with A, which has, well, you have 1 over 8. Or actually, let's start with the easy ones for A. 1 over 1. Woohoo! And then you have C again over 2, because 2 is a factor of 8. So all your factors here, 1, 2, 4, and 8, right? So 1 over 4 and 1 over 8. That's awesome. So hopefully, I mean, I'm hoping that 1 goes into it, because technically that's the only whole number solution. The others are not whole numbers. So if I'm testing 1, 8 minus 6 is 2, minus 11 is negative 9, minus 1, negative 10 plus 1 is negative 9. Positive 1 does not work. Does negative 1 work? Anyone try it yet? You guys tried it? Doesn't work? All right. Yeah, that means we get fractions. All right. So if we try 1/2. We try 1/2, we just put it up there just like we do any other number. 1/2 is a number 2. Actually, it's a number 1/2, but okay. What do we get? 4 and that's ugly. Huh? 2.5.
Yeah, negative 2.5.
So if you put it in decimal form, it'd be that. Either way, it doesn't work, right? No positive 1/2. Negative 1/2 doesn't work? Did you guys find any that work? Negative 1/2 does? Some people said it didn't. Now, you guys, I want you to just look at your neighbor's paper real quick and see if they've done any work here. Let's try negative 1/2. Negative 1/2, 8, negative 6, negative 11. Our coefficients there. Bring it down. We get 8. We get negative 4. We get negative 10. We get positive 5. We get negative 6. We get positive 3. We get 2. And we get negative 1, which is 0. It works. Okay. Very good. There could be at most 4 solutions. So this right here as an expression, how do I write that as an expression? Good. X plus 1/2. Just like that. Okay. This right here as an expression is 8x cubed minus 10x squared. Now, well, at this point, we're not to a quadratic yet. So let's factor by grouping. You can pull out a 2x squared. You're left with 4x minus 5. Will you get 4x minus 5 back here? If you put 8x cubed and 2 together, you can pull out a 2. You're left with x cubed. You're not going to get an x cubed in there. If you put 8x cubed and 6x together, okay, you could take a 2x out. You're left with 4x squared minus 3. You going to get that here? You know, it doesn't work. So, what do we have to do? Same thing again. List your possible solutions. Oh, hold on. Thank you. Very good. I even broke my rule first. Okay. Rachel pointed out, look, you haven't pulled out your greatest common factor, which is 2. All right. Now are we able to do factor by grouping? No, we still can't do factor by grouping, but it does make our groups, or excuse me, our factors easier, right? Possible solutions, we have 1 over, well, we have 1, 2, and 4. So 1 over 1, 1 over 2, and 1 over 4. Does 1 work? 4 minus 5, negative 1 minus 3. Nope, 1 doesn't work. Negative 1. Negative 1 just flips your odd powers. So this would be negative 4. This would still be negative 5. This would be positive 3. So we're at 6. So negative 1 doesn't work. Okay. How about 1/2? Okay, I want you guys to find which solution works there. Okay, which one works? 1/4 works. Okay, so we now have this. Hey, stay with me here. We're almost done with the problem. We have that piece as well as the 2. Okay? And I'm going to just move the 2 out in front of it. 2x plus 1/2 times, how do we write this as an expression? X minus 1/4 times, go ahead, 4x squared. Holy moly. All equals 0. Oh, we can take out a 4. That's good. So I'm going to pull that all the way out to the front. So the front's going to become 2 times 4 now, which is 8. Good job. Okay?
Simple math.
Yeah, back in the day. Okay, when I pull out that 4, I get x squared minus x minus 1. Okay? So 2 times 4, I'm going to go ahead and change that to our 8. Good job. Walsh there. All right. Can I factor? What do I have to do? You can do quadratic formula. You can do difference to, completing the square, graphing. It's up to you, but finish it up. Come on, you're so close.
This is just warm up.
All right. Ladies and gentlemen, that's what I've got for the quadratic formula. How many answers are right there? 2. How many answers right here? Positive 1/4. How many answers here? Negative 1/2. How many answers here?
0.
Yeah, it doesn't have an x, man. This doesn't matter. Sorry, 8. We don't care. Okay? So x equals negative 1/2, 1/4, and 1 plus minus root 5 over 2. How many solutions total? Real solutions are there right there? There are 4 real. Okay, how many are rational? 2 rational. This one's irrational because of the root. How many possible solutions could we have for this problem? 4. Okay? Yeah, man. Dun 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 dun. I'm loving it.
No.
All right, last one. Number 5. Guys, let's talk about this. Okay, write a polynomial function f with the least degree that has rational coefficients and a leading coefficient of 1. So in other words, it has rational numbers, and you don't have imaginary numbers as coefficients. Okay, the leading coefficient is 1, and your zeros are 1 and 5 minus root 2. Now, remember, we talked about one of our theorems yesterday. If we have a 5 minus root 2 as a 0, we also have a 5 plus root 2. And that just tells us if you're doing the least degree, how many zeros? 3. So this is an x to the 3rd power. That's just telling, that's what that means. Now from here, what I would do is I would write this 0 out. That's x as a factored form. How would we write that? X minus 1. This one right here, remember, I used the method where I just said, I know that's equal to x. That's one of my zeros as well. And to kind of work backwards, rather than saying that's equal to x, I am going to work backwards and find out the quadratic form of that. Okay? So if I move this over, that's going to give me x minus 5 equals negative root 2. I'm then dividing by negative 1. And then how am I getting rid of that root? Squaring it. And then when I square it, that's how I end up getting this other 0. Okay? So when I square that, it gives me negative x plus 5 quantity squared. And then subtract the 2 over. All right? That's going to give us this piece right here that we want so that we can write the polynomial out. Okay? That's going to take into account both of these zeros by doing that. All right? So we're kind of unsolving it. All right? If you're working this way, you've solved it. So this, when I square this, negative x squared is x squared. 5 squared is 25, and then this times this doubled is negative 10x. So we get negative 10x plus 25 minus 2, which is x squared minus 10x plus 23. Okay, that equals 0. That's what's in here. Why do that? Because we're trying to write the function f. So this is f of x. I think, by the way, yesterday in class I said f of x is supposed to be the function g. I made a note of that, but on our lesson. But now you have to multiply it out. That times that, that times that. Okay, we keep on going through.
Is this easy in comparison to the last problem, or is there going to be some catch?
Well, this one, you're just writing the polynomial. Should be easy. No catch. I don't try to trick you with the math. Just toughen. That's not a trick. That's trying to get you to evaluate. That is, hey, okay, I'm telling you, the Common Core standards tell you that, like, one of the standards is look at work and identify where the incorrect part to that work is.
Yeah, but it's not like you say, okay guys, I made a mistake. You're just like, hopefully they'll catch it.
You are 2 years advanced. Come on, I had to challenge you guys some, man. All right, hey, this multiplied out just so we can move on with life. Right now? Yeah. I am recording this period, I think. Yes, I'm recording right now. Okay? There we've got it. I'm not going to... I assume you know how to multiply these. So, okay? All right. Hey, we're done with the entry task. Whew.